Okay. Good afternoon. Hi, nice to meet you. I'm Daniel. We have some stickers here. If you didn't grab them up there in our booth, you can take it later with me. And I'm going to talk about the architecture Web3 was meant to have. Okay, let's keep this on. Okay, this is me, and this is actually this computer that I used to program in the 80s is the same as this sticker. So at that time, I had a vision of the future, beautiful future, where all the people would have access to computer almost for free in a decentralized and censorship-resistant way.
Eu vi sumes. Não, pai, vi sumes. Só um bocadinho, cara.
Are you okay? Okay, and well, I think after 40 years, at that moment I was 8-year-old, so almost 40 years later, I think my vision is starting to get reality. It's becoming a reality. And before I start my talk, I would like to remember you what is Web3. Because I think the term became a little bit changed over time, but we have to get back to the roots of what Web3 was meant to be. What do we want to build here? What are we building here? So the long-term thinking is we want something that is scalable but is decentralized. So we need to think about live clients, trustless bridges, utility-derived tokens, and all this long-term thinking instead of thinking about meme coins or small validator sets and cheating to get attention from the users. Because this is what some might be doing today. And remember that crypto, blockchain, DeFi, Web3, they are different stuff. And I think I'm here to build Web3. And of course, we can have a cryptocurrency, we can have a blockchain or DeFi protocols. But these are just parts of the revolution. The crypto is just a research, and the blockchain, a technology. DeFi is just a small piece of this. It's just a single vertical of the big revolution that we are building together. So what is Web3 in essence? Web3 is how we build this digital infrastructure that is resilient, that can resist of any kind of attack. This is what we are building. And sometimes we forget this and start building things that are not resilient and are not open for the public. And for that, to build this resilient infrastructure, we need to reduce trust, the need for trust. So Web3 is at the same time decentralized, verifiable, self-sovereign, interoperable, and privacy-preserving. These are the Web3 regarding to the properties. And of course we have blockchains that are public, are open, are borderless, are neutral, are data agnostic. And we also need to be resilient and all these things that we need, performant, accessible. All these properties reduces the need for trust. And why do we need less trust? Because we all know if we need to trust, sometimes we trust on parties that got into power, and when they get power, they tend to be corrupted. This is what happens over and over again, and history is here to prove me. Since 2008, and this is the reason why Bitcoin was created back then. And this is the reason why we created Ethereum. And this is the reason why we need to improve what was built on top of Ethereum to really be resilient. So Web3 is this revolution that we want to create. The way we interact with the world, not depending on central institutions, central infrastructure, central authorities. And of course here, in a conference about Ethereum, the first materializations of a blockchain that is meant to be a computer, we need block space. But we all know that Ethereum was not enough to offer to the main public this kind of space. But in the end, the blockchain is just this decentralized computer. It's a computer like that one that I was using back then in the 80s. It was meant to be just a computer. But instead of standing here on my desk, this computer is Ethereum. It's not physical, but it exists and I can use it without even knowing where it is. This is the idea. And it must be accessible and scalable for everyone, not just for a group of people that have access to the hardware or a group of people that are close to the owner of the real machines. It needs to be very, very powerful. And this is what Jam is. So Jam is the first next evolution of what Ethereum was meant to be. And this is the story that we are living right now. So Jam is the next generation of the blockchain computer. So we could say that if Bitcoin is a calculator, Ethereum is a single computer, and Jam is a cloud server or is a cloud system that lives by itself and we can just use very cheaply with a lot of performance, with the highest quality that any blockchain has ever built, without losing the values of Web3. Because some of the blockchains that were built after Ethereum actually were better, tried to improve what Ethereum did. But you see that in the end, they just chose some shortcuts that made them a little bit better in terms of scalability, but worse in terms of resilience, more centralized, giving up of the values, the original values of Web3 that we have. So this is a little bit of what we expect for Jam in terms of how faster, how better it is compared to existing solutions today. And I'm comparing it also with Polkadot, which is one of the chains that we have already running today, tested, beta tested, with hundreds of applications running on top of it, and Jam is just next level. We expect something that can run even 600,000 transactions, or maybe even more, because these are just estimations based on first glimpse of tests that we have, because Jam is not ready yet, but it's just around the corner, you see. Not only for computing power, which is what we have in most blockchains, but also to access data. Because what is a computer without a data infrastructure that we can can store and retrieve from. I remember when I was using my computer, that computer that you saw. I don't know if it appears here. Let me go back. Okay, where is the storage here? Do you know? Can you imagine where is the storage here? I can tell you. There's a small device here. It's outside the computer. It's a device, and you have like big disks like this that you put inside this, and you have stunning 1.2 megabytes of storage to run everything that you need. No, we don't want this. We want a lot of data access. And actually, today with Web2 providers, with cloud providers, Google, Amazon, Microsoft, we have this kind of storage. But this storage is in the hands of those companies, those entities. They are not our storage. They are not sovereign. We are not sovereign over this infrastructure. And we are moving more and more to use them without noticing that we are like giving our lives, the dependency of our lives to these entities. So yeah, we need a lot of data availability, a lot of data space. So in this case, GEM has 682 megabytes per second of data transfer capability, much more than any other existing one, even Polkadot. And not just, again, we don't need just capacity. We still need to be decentralized. We still need to be resilient for attacks. And another measurements, we yet don't have any measurements for GEM about this, but we can expect something similar to what we have in Polkadot, which is far beyond what we have in other chains. And mostly, we need to make it cheap. And cheap means the minimum amount of energy that is being consumed to run this chain, to run this infrastructure. So we need to be fast, we need to be cheap, we need to be resilient, all at the same time. And again, GEM goes far beyond any other thing that we know in terms of energy consumption. It's the cheapest that you can get from a world computer. And why not ZK? Exactly because of this, because if you put ZK in the scale here, so using ZK for layer 2s to scale the infrastructure, if you want to use ZK-based rollups, we're gonna have something even more consumption, a lot of energy. And we don't want that. Why would we have to use something that consumes 2 million times more energy than the thing that we have? It doesn't make sense. Of course, ZK can be useful for so many things, but for this, it's not sustainable, even if we can run it today with spending a lot of money, because of course, if it's 2 million times more expensive, we are spending 2 million times more money to run these computers. Maybe we have a lot of money today, but this is not sustainable in the long term. And I think most of you already know, GEM was created by Dr. Gavin Wood, the creator of Ethereum itself, the guy who built Solidity, who built the first Ethereum client. So someone that is very knowledgeable about all this history and knows very well what are the mistakes that he made. And he was humble enough to recognize his mistakes and try again. And this is why he started Polkadot. And this is why he started GEM, because he also saw that even Polkadot, which was meant to be this final solution for the dilemma of scaling blockchains had its limit. So Jam was created with this intent. And how can we get to this? How can we get with this? So much performance, so low energy consumption. How? It's just that Jam is the amalgamation of all breakthrough blockchain technology in existence up until now. So basically everything learned, all the lessons learned in the last 10 years, 15 years, building cryptography systems, put together into a single project. So we have like a RISC-V virtual machine, very performative. I think someone already talked about this today. Using Ring VRF, which is an awesome technology to create trust in a decentralized set of validators. So you can have a lot of validators and you can elect the validator who will author the next block without knowing who will author the next block beforehand. Very interesting way of using Saffron, which is the algorithm of consensus, together with Grandpa, which is another algorithm for block finality, and ELVS, which is the guarantee of security, the auditing system. So if you put all this thing together, ELVS, Saffron, Grandpa, I know it's a lot of names that maybe you never heard about it, but each one of these are solutions for specific problems, and if you put everything together with eraser coding, which is another technology already used in many other data availability systems. How do you make data available, but yet scalable? You need to spread data through thousands of servers. How you make this efficiently, cheap, using erasure coding, and quick, which is a new protocol for networking, efficient again. And all of this specified in a formal way. And why is Jam specified formally? Because it needs to be implemented, freely implemented by a lot of people. We don't want to have this beautiful list of technologies being implemented by a single team, by just one company, because this is not resilient. Again, we don't want to depend all this marvelous technology into one company. We need to make it open. We need to invite others to implement this protocol. So Jam is specified. It's already specified in what we call the gray paper. And this gray paper has everything you need to know to implement it from scratch. And this is how I became a Jam implementer. I just took at this paper online, downloaded, started reading, a lot of math formulas, a lot of complexities, and learned all these pieces little by little, and now I'm working on one of the 35. Say your team, your name and your team.
I'm Francisco and this is Oliver from Jam Brands.
Hello, my name is Emil and we are with Gentle Technologies building pajamas.
Yes, we'll see here. I'm Martin.
My name is Lizzie and we are new generation. It's here from Lollipop.
You are Loka Jam.
Name and team.
It's Rob Yogi, Jam Tuna from Confluent.
Juhan Park from Festival.
I want to, it's a long video, it's a full buzz of Jam implementers. We have like 35 teams implementing Jam in 15 different programming languages. Thankfully, this buzz was not bombed, so we are still here now in a more decentralized way. And a few more things. So we all know that the experience, the developer experience for building on blockchains is kind of rubbish, right? We want to improve this also. We want to make this experience as smooth as building on your own computer. This is what we want. We don't want to think about gas fees or block space or block size or all these underlying things that are for the infrastructure, but the developer that is building the app shouldn't need to think about all those things. And with Gem, we can do it because Gem works exactly as a computer. Blockchain is just a decentralized computer. But how can we achieve this? So I'm going to talk a little bit about what Gav calls the side synchronous antagonism. And this is the reality of all the systems that we build. If we need a system that is big, it becomes little by little. The bigger the system is, the less coherent it is. So what does it mean to be coherent? It means that parts of the system is already updated with the latest version of the data, and parts are not. We see, for example, the Ethereum and its layer 2 solutions. Why it's not coherent? Because what happens into a layer 2 is not available for all the layer 2s to know, or even for the main layer 1. It's just aware of what happened into the layer 2 when the transactions that settles that thing goes to the main chain. So there is a partial time when things are incoherent. And this is a big problem because if we want to scale, we need to have something incoherent. But at the same time, we need to make something big and accessible to everyone. So it needs to be this big system. So Gem tries to balance these two forces, the force of being huge and the force of being coherent, and try to deliver for the end user something that is what is called semi-coherent. So Gem is join accumulate machine, a semi-coherent design. It is coherent every 6 seconds. So it is coherent and then it passes a little bit of time, a little bit incoherent, but immediately it gets coherent again. So this is how we achieve that. We can get it really big and deliver for the end users some kind of coherence that is enough to run a lot of systems that were not possible before. So we want something, the idea of something that is flowing and is running without any interruption. This is the ideal world of running a lot of things in parallel and completely smoothly. And Ethereum was kind of this. You have things that are running a little bit, just a little capacity, so there's not much capacity. You have all these nodes that are running the same thing, and this was to be the centralized computer. So in the end, it's just like it lags. It runs a bit, and there's a lot of time to get the next one. Then a lot of times to get it. It's coherent, but it's slow. It's coherent, but it's very, very incapable of running everything. And then other chains try to make it faster and again more capable, but losing the main trading the Web3 principles for performance, which is not acceptable. And then we have Cosmos that is like kind of trying to divide and conquer sharding, but it's not a real sharding solution because it's splitting the security also. So the solution that Polkadot had 5 years ago was like, okay, We need to charge, but we can't give up of security. We need to be sharded, but be secure at the same time. So have a shared core of securities. And this is what Polkadot was 5 years ago, and there's a lot of folks that work on Polkadot here to confirm that this is how it is. But yet, you still have the problem of fragmentation and incoherence between what we call rollups or part chains. So parts of the system are still not aware of what is happening in other parts. And even if they can send some messages to each other to make a little bit of communication, it's still not so smart. So the solution doesn't work well. Gem is this kind of like crazy stuff that goes in and out data. And of course, I would have to spend almost a week with you to explain all the details of Gem. It's, by the way, I'll have a link in the end. If you are more interested in Gem, there's a lot of resources online to learn more about it. And there will be a course in the end of the year in December in a very nice location. And if you want to subscribe to this course, I will leave the link in the end. It's an on-site course. So, how to make this complex thing a little bit more accessible? There is this concept that we call Core VM. What is Core VM? Core VM is a software that is run on top of Gem. Okay, think about this way. Gem is a computer, right? But computers without software is nothing. It's just a machine that doesn't serve for anything. We need to have an operational system or something that runs on the machine that helps others to run on the machine. And this is exactly what Core VM is. We can somehow compare it to the Docker for Gem. So instead of you as a developer having to write machine code to talk directly with the machine, which is really difficult and sometimes a lot of work, we build this second layer of abstraction. You don't need to talk with the machine. Even if you can still do some machine calls, but we facilitate your life, giving you another environment where you just have higher level abstractions, where you can call more easy to use functions and interact with this machine without knowing what's happened underneath. So the Core VM is this service, one of the many services that can run on top of Gem. So basically, Core VM actually transforms Gem into this continuous execution machine, like the computer. So what does it mean for the developer? It means that you can create a software, you can create a code that is actually any program, even infinite loops you can run on top of Gem. And there's actually, you saw it in the booth probably, there was this experiment that we ran. Yeah, like this guy showing. It's kind of, yeah. It's running Doom. Take the bytecode.
Is out the top of the list. It's constantly, churning through compute. It's running on the core of the jam of this computer, this decentralized computer. And you can see it's taking up 5% of the riff.
Yeah, just a snippet. There's this full video. I can share share the link with you later. So basically, you take any software, you deploy it into this Docker machine, and it runs. And it has video, and it has not only video. It has other. Let me see if I can. Oh, I didn't have this slide. Sorry. Maybe let me just use this one. Oh, here. Just this one, I missed this slide. Let me do some editing in real time here for you. Okay. So basically, it's a computer that has video output. It's still being written, the audio driver, the terminal output, keyboard input. So basically, you have all the APIs that you would have from a regular computer to interact with the user from inputs and to outputs easily. So this is what Cukier. It's still being developed by some of these guys, but soon it will be available. Okay, how are we with time? Do we have a little bit? I'm running out of time, or it's okay? Okay, so do you have any questions? Let me pause for a bit for some questions. Maybe it's a good moment. Oh.
Yeah, I'm wondering what infrastructure might be needed in general for Jam, like validators or service providers.
Okay, so Jam runs in a regular server machine. So basically, any simple server with maybe 8, maybe 16 gigs of RAM and maybe 1 terabyte of storage can host a Jam node. The chain is planned, even if this number can change, but the first Jam network will be 1,023 nodes. So basically, this is the amount of nodes that will be part of the chain. It's a fixed amount. And
Are they defined already?
yeah, this is defined right now. Of course, this can change because there is this data center that we call the Toaster that was built here in Lisbon, in the neighborhoods of Cascais and Estoril. There is a hidden data center that has a lot of machines, and they built this not to run the real chain, of course, because it's a single point that it's centralized, but it was meant to simulate real-world environments with the full chain. So basically, this data center will be capable of running all the 1,023 nodes into a single place to make all the simulations that we need to make before the chain goes live. So I think no other blockchain has something like this. Because all the blockchains start with start with 3 nodes, with 4 nodes. No, we will start with 1,000 nodes. But before that, we need to test how it is to run 1,000 nodes in a real environments with real applications, how many transactions we can do per second, how many applications we can run in parallel. So the infrastructure is still being built, but we already have a part of it here in Portugal. And all these Jam teams that you saw there in that video over there, okay, all these people, I can, okay. I can't mute. I don't know why I can't mute. Is there a way to mute? There is a way to mute. Yeah.
Say your team.
Okay, I can mute. No. So all these 35 teams will have access to this hardware, and this is just the first step, because once we have the network running, we're gonna have the builders building, and this is why we are here today, because we are inviting you to start exploring Jam as an environment for you to build your applications, to build the services. You have a question? Yes.
So first of all, there will be more than 1,023 nodes. It's just that for the sake of 24 hours, this is how many nodes are selected to participate in the algorithm, in the protocol. Okay. And it can change over time. So there will be potentially many thousands of nodes and only 1,000 of them selected for a day. Okay. And on top of that, just to make sure that everyone gets it right, that infrastructure here in Portugal is for testing purposes. Yes. This is not, Jam will not be run on it, just to be 100% clear. We don't know who will be running Jam. It will be fully decentralized through a staking system, so God knows where the infrastructure will be.
Exactly. Thanks.
when will the chain go live?
Well, this is a very good question, and I don't have the answer for that. Unfortunately, I would like, but I think it's expected to be maybe by the end of the year, maybe beginning of the next year. Probably the testnet will be live this year, and the main chain next year. Because one question that a lot of people have was, okay, is this Polkadot, or Polkadot has nothing to do with Gem? And this is a very common question. And one of the challenges is how can we migrate Polkadot to run on top of Gem? Because this is the end goal. Instead of having Gem as a separate thing, Gem will host the existing Polkadot ecosystem and all its software that is already working. And as you saw previously, and also we have Kusama as well, so probably there will be a Gem for Kusama first and then Gem for Polkadot. So all this is still being developed. Even if the chain is live, probably there won't be so much, because if we don't have the services and the things that are running on top of it, it's just something that is running, but it's not, it doesn't have any real application. So it's a road without cars. So, of course, phase one was like all the testing, make the testing work very well in this toaster environment, and then making a real testnet, decentralized with a lot of people. So I would say that by the end of next year is more, it's just an estimation on my side. I don't know if you have any other expectations.
I think that's fair.
Yeah, I think it depends a lot on many things, but one thing that is very important to tell you, the Gem, the gray paper, which is the specification, was released in May last year. So basically from the specification, which is just a paper with a lot of math formulas, to a full chain running in a year is very, 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 very fast, I would say. So there are a lot of very talented people working on this, but to have it production ready, I think it would take maybe another year. And I would say this is faster than any other thing you see in the crypto space. So Ethereum took like 3 years just to change from proof of work to proof of stake, and now it's taking another 3 years to change from whatever next. Because like it's hard when you have something running, it's really more difficult to update it, to change it. But anyway, yeah, so there are a lot of people working hard, and we are here just because of this, because we wouldn't be here also last year. We didn't have ETHLisbon last year, but we could have been in other Ethereum conferences to talk about this before. And this is the first ever conference that we are coming to make you aware of this network, because now is the time to start looking at it in a very early stage, where you can already, and I'm going to give you some links that you can follow and start exploring the idea of building on top of it. It's the first, let's say, very, very raw material for you to explore and to build. So let me give you some, because we are running a little bit out of time. Okay, these are the links. So we have what we have today. Yesterday we just released the Polka Gem team, which is the party, one of the implementers. They released the binaries of their node. So they are already implemented, even if it's not complete. Of course, there's a lot of improvements that they need to do, but there's already a binary. And why a binary and not the source code? It's important to know that there are 35 teams implementing it, and we don't want that each team looks into other teams' code. All the teams must have a clean room implementation, because we want something very resilient, bug-free. If I look into your implementation, maybe you have a bug, I will copy your bug. So all these teams are working separate, and those who finish, they can share their binaries, the way this team did. So others can run the node, using the binary without even looking at the code. And the node will work in accord to the specification. So basically the node will follow all the specification, and if you have a node written in completely different technology, if they actually follow all the protocol formulas, they will be able to talk to each other. And this is what we have today. So we already have these nodes that you can download and run in your computer. And we already have, of course, a still early stage version of an SDK for you to build a service on top of Gem. So basically, if you use this SDK, you can create a program in Rust. At this moment, it is Rust, but you can later use this Rust binary and use it in other environments. You can plug it into your favorite, because Gem runs on top of PVM. I don't know if I talked briefly about PVM, but PVM is a RISC-V machine. And it's a machine, it's an ordinary machine. As you saw, Doom was not programmed back then to run on Gem. Doom is just a random C code that you compile. So you compile to RISC-V and it can run on top of Gem. So anything that compiles to write RISC-V can run on top of Gem. And this is the Rust SDK, the Gem PVM SDK, to help you to transform your program into something that can run on top of Gem as a service. And so basically, if you take this thing, make it a run, and then when it's running, you use this thing to deploy the code into here, you have something running on Gem. And you can start exploring this. Even if we are still early stage, the documentation is not the best one that you could ever had, but you are here also to help us to improve the environment. So everything is welcome. And if you want to deep dive into Gem, we have this thing called the Polkadot Blockchain Academy. It's an in-person technical course. Gavin Wood, as a lecturer himself, explaining in details what Gem is, how to use all these tools to build something on top of it, and the idea of this course is a very practical. And we want to have the most innovative entrepreneurs, creative people that look at this machine as a blank canvas and say, okay, what could I run on top of this that I can't run anywhere else? I can run this on Solana, I can run this on Ethereum, I can run it on Near. Can I run it this kind of software here? Let me try. So this is the idea of this course, to discuss, to prototype, and maybe come up with some real innovations. It will be in an unforgettable location. I want to tell you that it will be in Japan, so, but yeah, and Dr. Gavin Wood will be the lecturer. And yeah, you can scan this QR code if you want to sign up for the course. If you want to know more, I had a lot more slides here, but unfortunately I didn't have too much time. But I'm more than happy to come here another moment if there's room available and people interested into going, even with help of my friends, because I'm still learning. Even if I'm working with this for 1 year, I think there's a lot to learn, and I'm struggling to learn and help you to learn as well. So I can give more details of how these things work under the hood and what are the components of all these technologies that we have here. So if you go to the gray paper, and you have a chapter for each one of these things and much more, it's complex, but in the end you have that reason. Question? Yes.
Is the gray paper publicly available?
Yes, of course. The graypaper.com. Very easy. Gray with an A, right? Because it's the color.
Okay.
So if you search gray paper, yeah, you have this. Yeah, I think that's it for now. Let me see if I have anything else for you.